Hey everyone, in this video we're going to be looking at managing files in a Linux-based file system. Just as a general outline of what we'll be covering, we're going to first take a look at where things go. How the file system's laid out, what sort of files go into which different directories and so on. Then we'll move into navigating directories, we'll talk about manipulating files, and then we'll wrap up with manipulating directories. So first, let's try to understand where things go. We have a notion of user files and system files. So system files are files that control the computer operation. They're ones that are used by the kernel. They're critical for the operating system to work correctly. Some examples of those would be startup scripts. So any startup scripts like what kicks off the GUI and what gives us the logon screen, what kicks off any administrative programs, etc. Program files, program support files, config files, data storage, and system log files. So all of those could be considered system files. And then on the other side, we have this notion of user files. So user files would be like something that belongs to the user. Typically, these will reside in the home directory of the particular user, and it would be something like Excel documents or MP3s or pictures, Word documents, etc. Now, as part of this understanding where things go, there's this thing called the File System Hierarchy Standard, or FHS, and it talks about 4 different classifications of files. So we have shareable and non-shareable files, so ones that we can share with other systems, ones that we can't. And then we have static files and variable files. So static files are ones that typically aren't going to change, or they're not going to change often. Variable files are ones that are going to be changing pretty rapidly. Okay, so we can line these up into a matrix and we can start classifying different directories on the system based on these 4 characteristics. So for instance, we can have some static files, ones that typically don't change, might be located in the etc directory, which is where we keep configuration files, but they may be unshareable, or they should be unshareable because they're going to be dependent upon the system that they're running on. So we have configurations in here like host name and the different user accounts on the system, the passwords for those user accounts. We wouldn't want to share that with another system because it should have its own configuration. Same thing with boot. But there are some shareable static files like what we might find under the USR directory. So we've looked at like USR/bin has different programs in it like Free and Firefox, and in those programs they're not going to change that often to where that we can't share them. When they do change, typically an administrator would go in and just upgrade to a new version, and then that still in itself would be shareable. Now we also have some variable files that would be shareable. One example of that would be like home directories. So home directories, the home directory itself has a subdirectory for each user account, or at least that's the default way that it's set up in a Linux-based operating system. These directories would be shareable. That's how I could log into one system and do some work and save it, and then log into another system later on and be able to pull up that same document. If the way that that's possible is if the home directory is being shared. Same thing for mail. If we're getting mail on our particular Linux-based operating system, then we should probably share that too, because basically the user is just going to be able to access their particular mail account. Now, some unshareable files that are variable would be like locks, or well, like it shows here, stuff under var run and var lock. So as we run programs sometimes, it can be the case that only one user can run that program at that moment, maybe due to the way that it's accessing data or the way that it's accessing device files. like hard drives or some other piece of hardware that we've hooked up to the computer, um, those are lock files and they stop another user from being able to run that program. Okay, but a lot of that is just dependent on the particular computer that we're running that program on. And another computer should be able to run that program and access its own devices just fine. So we would not want to share any of these var run or var lock type of files. So let's look at a few important directories and what sort of things that they contain. I've already alluded to the fact that the etc directory contains configuration files. So when we install a program, we typically will install the binary or the executable portion of that program in an executable directory like sbin, bin, user sbin, user bin. There's quite a few of them. Each one of them has slightly a different meaning. And configuration for that executable would typically be located in the etc folder. So we could go into the etc folder and we could quickly make modifications. And it's kind of a one-stop shop when it comes to making configuration changes for applications. Additionally, we have some library directories. So libraries are like DLL files in Windows. They're called shared objects or SO files, and they are they're libraries. They contain programming functions that have already been compiled and can be shared amongst other programs so that they don't have to include that code in their binary. We can typically find these libraries under /lib or /usrlib. So here's just a table showing some of these directories. You may have noticed so far through the previous lectures that everything is based in the root directory. So the root is the start of our file system. Usually the way that I describe this is it's sort of analogous to the C drive on Windows, the absolute root of the C drive. So all other files and directories appear as being underneath this root directory. Alright, so one of those directories would be etc, and we've already talked about how that contains configuration files. One would be boot, and that holds important boot files like the kernel and the initial RAM disk that helps get us booted up. And then sometimes some other bootloader configuration files. Bin, this holds our program files, so this would be where our binaries go. And bin is usually just used for ordinary users may run anything that's in there. Then we have sbin. So this holds critical files that ordinary users don't normally run. So I like to think of the S meaning super user, where this is normally where an administrator would be running programs from. We have lib. We mentioned lib holds libraries, and that's code that's used by other programs. So this is very critical in that if these libraries can't be found, these programs can't run. With the USR directory, and this holds programs and data that are used in normal system operation, but they're not critical for the bare bones boot of the system. So we end up getting this other sort of structure or layout underneath USR that also contains a bin, sbin, lib, and so on. And it seems to be just kind of repeating these other top level directories. And the reason for this is back in the day, disk used to not be that big. And with disk not being that big, we'd have to basically have everything that we need to boot on one disk. So we would have these bin, sbin, and lib on one disk, and then after we've booted up enough to where we can mount another disk, that other disk would come in with like USR bin, USR sbin, and so on. So these would be supplementary things that aren't necessarily needed to boot the system, but they're still we still want those, right? Because that has additional programs like maybe Firefox or word processor, something like that. Slash home, this is a directory that typically has subdirectories for each user that has been provisioned on the system. So it separates this directory into its own low-level file system, effectively isolating most user data from the operating system, which can be useful if you want to reinstall the OS without losing user data. So sometimes we talked about partitioning a few lectures back. Sometimes people will put the home directory in its own partition so that they can blow away the operating system but still keep the home directory on the new operating system. So slash root is an exception to this home directory in that the root user has a separate directory where it houses its home directory, and that's just slash root. Slash var usually just holds transient files, so you'll find log files in there and print spool files that are jobs that are being sent to the printer. And there's some other subdirectories like var temp that deserves a special meaning, like temp that's described next. Var temp holds temporary files, and these files should not be deleted when the computer reboots. Now that's in contrast to slash temp. So when the computer reboots, var temp will still be around, but we can't guarantee that slash temp will be. Okay, so speaking a little bit more about that, we just put temporary files in here. Sometimes other programs need to create temporary files or whatever they need to make a file for, but it doesn't need to persist between reboots. So they'll just create it in slash temp. That way they don't have to worry about it later on. Now, the book says in practice many distributions don't delete slash temp, but most of the ones I've seen do. But apparently there are some out there that don't, so just keep that in mind if you're wondering why maybe slash temp's filling up or something. It could be due to that. Slash MMT, this is the traditional mount point for removable media. So if we enter something like a USB stick or maybe an external CD drive, we would mount that, which is the process of creating a directory in this root file system for accessing that particular device. It's a lot less complicated than it sounds. Basically, there would be a subdirectory under here, and when we access that, that's how we would get access to that USB stick. That's in contrast to the way it works on Windows. So when we put a USB stick in the drive on Windows, it will usually create a new drive letter like G or H or I and assign that to the USB stick, and that's how we'll access it. So slash media, this is a newer mount point for removable media, and all of these are just conventions. So we could put we could mount our removable media anywhere, but typically it's going to be in one of these folders, mount or media. Slash dev, that holds our device files. So one thing that we've seen that already goes in there is our hard drives like SDA and SDB, and then the partitions like SDA1 and SDA2. We can find those in slash dev, along with many other device files. And then slash run holds information about the running system. Okay, so let's get into the fun stuff. How can we navigate around files and directories? Well, I think in the last video we mentioned this ls command, and the ls command is used to list out the contents of a directory. So if we pass no options, ls shows the files or directories in the current directory. So there's this notion of a current working directory. Where are we at in the file system? If we jump over to Ubuntu, okay, we can open up a terminal, and let's also open up a file explorer. Okay, so what we see here is in the shell prompt, we have our username at our computer name, it's whatever we named our computer during installation, followed by a colon, and then this tilde. Now the tilde has a special meaning. As far as a file path, that means the current logged in user's home directory. So student here. Let's see. Let's go to computer. So right now we're at slash. This is the root of our file system. And you see this home directory right here. Well, underneath there is going to be a folder or a directory for each user that's been provisioned. Well, we are a student, so this is our home directory right here. So that's where we're currently located. We call this the current working directory. So if I type ls and press enter, I'm going to see the contents of that directory. Okay, so that's what we're seeing there. Now if we pass in a directory name, ls is going to show us the files and directories in that name directory. And there's also various other options that we can use to control the information shown, as well as the way that it's shown to us. So let's just look, I'm trying to think if any of these have anything in them. I guess let's look at the documents directory. So if we ls documents, so I just want to look into that, press enter. Okay, so we got no output, that means there's nothing in there. So if I were to come over here, we could verify that. Double click on documents and we see that that's an empty directory. And maybe I come over here and just do a new document, empty, and we'll just call it test. Let's try this. ls documents, now we see our test file. Great. So what are some of these other options that we can use? Well, ls takes a ton of options. So I'd highly recommend that you read through this list, familiarize yourself with some of them. Also take a moment, read through the man page. The man page does a good job of describing what each of these command line arguments do. So one that we'll use a lot is the -l, which is for long listings. So when we do that, instead of just showing us the directories and the files, what we see is a lot more information about each one of those. So we see the permissions here, we see the inode count, which we'll get into later on, we see the owner and the group owner, the size in bytes, and the modification date. Okay. So an example here is they're using the -f option. So if we jump back and look at -f, this command appends an indicator code to the end of each name so you know what type of file it is. Well, let's come over here, and if we do an ls-f, you can see what it does is it puts a slash on the end of directories. So you're not always lucky enough to have this nice color code that you can look at and just automatically know that blue is a directory. Sometimes you can correlate that back to the file type. So this D right here indicates directory and this dash indicates a regular file. But if we use -f, it'll throw a slash on the end, or it will not do anything on the end if it's just a regular file. It just makes it easier to know the differences. Okay, back on this page, there are some long form options. So sometimes the long form ones are just easier to remember because it's a word versus -f. Doesn't matter which one you use, they both do the same thing. So just to show you, ls-classify does the exact same thing. Okay, we've looked at the long listing, and we're going to dig into some of these parts later on in the course. But I guess it's good to mention here that we can also use wildcards. So as we're listing things out, we can list all the things that start with T by specifying a T followed by a star. So the star means just match anything else after this. So we can see that this returned test, thttpd, blah blah blah, toms rtbt, blah blah blah, and tripwire.rpm. So those would be the ones that are in the current working directory that start with T. Again, if we wanted to look in a different directory, we would need to specify that directory somewhere right here at the end of the command. Alright, so let's look into changing directories. The cd command is used to change a location, and pwd can be used to show a location. So let's look at how both of those work. Over here, let's start off with pwd. So that prints our working directory is what that stands for, and it shows us what our current working directory is. So /home/student, that's where we are over here. Now let's say that I wanted to navigate into documents like I did over here in the File Explorer and see the test. I can do cd, and where do I want to change directory to? Documents. So documents is in the directory that I'm currently in, so I'm just going to paste that there, and then I can do an ls, and I see test is in my current working directory. So hopefully it's becoming clear that Linux uses this unified directory tree where everything exists underneath this root, or the root directory of our file system. So this allows us to have things like subdirectories: home, user, etc, bin, media, and some of these can exist on other hard drives or other storage mediums. So for instance, we can have the home directory exist on this dev SDA5 partition, whereas the root directory might exist on dev SDA1. So user, etc, bin, and media would all still exist under dev SDA1. But then we could have a DVD directory and a flash directory, and both of those are coming from different devices, like dev DVD disk or dev SDB1 for a USB flash drive. Alright, so as we are changing directories and we're referencing files, we need to know the difference between two different types of file paths. There's absolute file paths, and then there's relative file paths. And it's a pretty straightforward notion to understand. An absolute file path is one that always starts at slash. Okay, so if I wanted to give the absolute path to Sally's home directory, it would be /home/Sally. Now that's in contrast to a relative file path. Let me see if it covers that over here. So a relative file path is one that's relative to our current location or our current working directory. Alright, so let's take a look at that. Let me change directory to the root file system here. Now before, when I was in home/student and I wanted to go to the documents folder, I simply typed cd documents. Now if I try that here, it says that there's no such file or directory. So it could not find that anywhere. And that makes sense if we list out the contents and we see, well, yeah, there is no documents directory, because that documents directory exists inside of home, inside of student, and then that's where documents is. So this is a good example of a relative path, the way that I used it before up here. When our current working directory was home student, I was able to change directory to documents and it knew exactly where to go. But here, my current working directory is the root directory. So if I want to change directory to that home student documents, I need to do it this way. I need to specify an absolute path. So home, And here's another great use case for the tab key, so we don't have to type all of this out. Just press tab. And that takes me back to where I was, and we should see that test file there that we created. Okay, so additionally, there are two other things I want to talk about here when it comes to relative paths. So based on our current working directory, where are we at here? We're in home, student, documents. If I want to go back one directory, there's two ways that I could do that. I could exhaustively type out home student, so change directory there, or I could change directory ... And what ... is that says go back one directory. So when I do that, I've effectively gone back one directory. And you can actually see this in the listing. If we do a long listing, you won't see it here because it starts with a dot, and dot files are hidden in Linux. So we didn't see those in home either. We didn't see a ... But if we use the -A option, and we can use that in conjunction with -L, there's a lot of other files in here that we're not seeing. And that's because they're hidden by default when they start with a dot. Let's scroll all the way up to the top though, and you'll see that there is this dot, and then there's a ... So the dot can be used to reference this particular directory, the one that I'm in right now. And the ... obviously goes back one directory. Okay, so that will definitely help us to get around on the file system. And we can see a little example here that they did where they printed their working directory, they moved back one, and now we can see that they're back in the home directory here. Now the other type of I guess file reference that I want to mention is this home directory reference. We've already talked about it, but it's that tilde. So tilde by itself will take us to our current logged in user's home directory. Now if for some reason we had access to someone else's home directory like Rich here, we could do a cd tilde rich, and it would take us here to /home/rich. Additionally, I'd mentioned environment variables in our previous video. There's an environment variable to represent where your home directory is at. So $home, we can see what's stored in that is /home/student. That's my home directory. Okay, so we've learned a little bit about how we can move around the file system. How can we create files though? So one way we can create files is we can use the touch command. Now touch doesn't do too much. Basically, if that file does not exist, then it's created. It's created, but it has no size. There's nothing in it. If the file name does exist, then the access and modification timestamps are updated. So let's take a look at this. See if we can look at an example. So let me go back to documents and ls. So we see there's test there. Let's do an ls-l. And then let's touch test2. So that went out. It created a new file on the file system. And we see that there is test2. We also see that it was created at 350. That matches up right up here, 350. And the size is 0 bytes. Now, if we want to update the timestamp on a file, we can say touch, and let's update test, because it was 334. Now, if we do an ls-l, we can see that the timestamp's been updated now to 350. So that's pretty much the significance of touch. Really useful to update a timestamp, or if you just need to create an empty file. So next, let's look at how we copy files. So copying files is a pretty easy thing to understand. Get back into documents here. We can do that by right-clicking on a file and going to Copy, and then right-clicking in the folder and selecting Paste, and that'll make a copy for us. But we're interested in how to do that on the command line, so we see our three files here, test, test2, and test copy. Let's make a copy of test, and the way we do that is with the cp command. So real quick, looking at the man page for it, you can see that there are some options, and what these brackets mean is that this part is optional. We don't need to have options. Same thing here with the -t, and what's underlined is what's required. So cp source destination is the easiest way that we can call the copy command. So let's make a copy of test. So cp test, and let's call it test3. So ls, and now we can see that test3 was created in that same directory. Now we don't need to always do it in the same directory either. In fact, either one of these, both of these right now are relative paths, but either one of them could be absolute paths if we wanted to. Why don't we try this? Let's make a copy of test and go back a directory and put it in downloads and call it test4. Okay, so we're going back one directory into the home directory for student, going into the downloads directory, and we're going to call this test4. So let's see that up here. We're in the home directory, downloads. We should see test4 appear up here. And there it is. The copy was made. We can do an ls and see there's no test4 here. But if I change directory back and go into downloads, we can see it there. Okay, so if we're going to keep the same name for the file and it needs to go in a different directory, then we can just specify that other directory. But if we want to give it a new name like we did, we called it test4, then we would specify the new name for that file. Move is very similar to CP. Only difference is it doesn't leave the source. So move can also be useful to rename files. So looking in here, we have test4. Well, what if we wanted to move test4 and let's call it my file instead? So we're basically just renaming there. If we do an ls, we can see my file. But I could also move my file back one directory into documents. Okay, we saw it disappear there in the file explorer. We can also verify here that the directory is empty. And if we move backwards into documents, we see my file exists right here. Okay, so we can use the mv command to either move the file or to simply rename the file. Alright, and another type of file are called links. So there are two different types of links that we can create. These are like shortcuts in the Windows world. So there's hard links and then there's soft links. So we mainly deal with soft links, but let's talk about hard links for a second. This is a duplicate directory entry. It can exist only on a single file system. So what that means is if we have a hard link on one particular hard drive, then if we mount up a second hard drive in a different directory on our root file system, we can't do a hard link over to that original hard drive. The way that we create links is with the same command as ln for link, and it's the original name followed by the link name. So the file that we want to link and where we would like to link it. And one thing you'll notice is that you'll see the link count increase, the inode count that I had referred to earlier in the ls output. So let's take a look at an example of this. so we still have these files here, and if we do a long listing, we can look at the inode count here is just 1. So how many times is this file being referenced? Just 1 time. Now, if I create a hard link to my file and call it my hard link file, we can do an ls, and we see that my HL file. If I do a long listing, we can see that there are 2 references to these files. Basically, both of these are pointing to the same file in the file system. Okay, so it's called a reference count. The neat thing is I can remove my file. Okay, so RM for remove or delete. Do an ls, we see it's gone, but there's still this my HL file. If I do an ls-l for a long listing, the reference count has been brought down 1, but that file still exists. Okay. This is in contrast to a soft link. So a soft link is also called a symbolic link, and it's just a file that holds another file's name. It can move across file system boundaries. It doesn't really matter. It's kind of like a shortcut in that we're saying, hey, when someone tries to go to this file, instead, let's send them to this file over here. So in this case, let's do a soft link to test. So ln starts off the same way. The only difference is there's this -s flag. And let's specify the file that we want to make a link to. And let's call this my soft link file. Okay, so if we do an ls, we can see all of our different files here. You may notice that there's some highlighting going on, and that this is blue, and that's just to indicate that it is a soft link. If we do an ls-l, we can see that some things look different about this line than this line down here. So this is our permission string, and the permissions are 100% accessible for anyone on a soft link. And that's just because it follows that link to where it points to. So this one points to test, and it enforces the permissions there. Alright, so you're not going to get around permissions by using a soft link, but it is kind of surprising to see these permissions sometimes. Now, another thing you may notice is that the inode count did not increase. We don't have a second file that's pointing towards test. We just have this file here that contains the path to test. So if I remove test and I do an ls-l, we can see that this is turned red, and what it's indicating to us is that the file that this points to does not exist anymore. Right? It's a dead link, but it still exists out here. Okay, so hard links change the inode count. It's effectively just giving an alias to this file, saying, alright, I'm going to call it this, and I'll also call it that. Whereas a soft link is more or less just a level of redirection. We're saying, when somebody wants to go here, really send them here. So deleting files. We actually just alluded to that just a minute ago, but rm is the command that deletes a file. So we come in here and let's get rid of those soft links and hard links. So remove, okay. If we want to remove a directory though, we need to use a special flag with this rm command, and that's the -r. And what that does is it recursively goes through and deletes everything inside that directory, and then once everything's emptied out of the directory, it'll delete the directory itself. Okay, so let's come back over here. Let's look at a man page for RM. So let's look at dash R, get down to this one, and this removes directories and their contents recursively. Basically what I just said. The other option I want to look at is, oops, if I can type it, dash I. Okay, I didn't find it. Let's go backwards. Oh, that's not it. Dash lowercase I is going to prompt before every removal. All right. So that's a safe way to delete, because Linux is, if you tell it to delete something and you have permissions to delete it, and even if deleting that something is going to completely make your computer unusable, it doesn't care. It will go out there and delete it, and you'll be left with an unoperable operating system. So, lots of times, and sometimes operating systems will make aliases for this, where when you type RM, it just automatically supplies the dash I so that you don't accidentally delete something that you shouldn't. So let me show you a little bit more about what I'm talking about here. We have all of these files inside of documents, right? All of these test files that we created. And let's say I just want to delete the documents directory altogether. Well, I can't just say remove documents, because it says that's a directory. Now there's another command called rmdir, but it only works if the directory is empty. So you see it says directory not empty here. So what can I do? Well, I can cd into documents, and I could individually remove test2, test3, and this test copy. But that sounds like a lot of work, right? Really, I just want to blow away this directory and all of its contents. So I can use this -r to recursively go into that directory and remove things, and then ultimately remove the directory itself. Okay, so that's what that did. We can see there's no more documents directory. Now, just to illustrate the usefulness of the -i, let me recreate that directory. So mkdir stands for make directory, followed by the directory itself, so documents. So we just created that. We can get in here and we can touch test2. We'll just give ourselves a few files, right? Okay, so let's go back. Same situation. I want to get rid of documents and everything in it. So rm-i and r. So I is going to interactively ask if I want to get rid of those files, and r is going to recursively delete them. Okay, so first it's going to say, hey, is it okay if I go into this directory? Sure. Is it okay if I remove this file? Yes, yes, yes. And can I remove this directory documents? You know, if we didn't want to, we could just do n for no. And we see the documents is still there. But if I go into that directory, all of those files that I said yes for are gone. Okay. And lastly, now that we have an empty directory that we can work with, we can do an rmdir followed by that directory name. And then there's no problem getting rid of it. So I'm just going to create that back so I still have it. Okay, so as we're dealing with files, we can use wildcards. I had talked about the asterisks, and the asterisks will just match anything. The question mark can be used in place of a single character. We can also use bracketed values to say any of these particular characters would be valid in this one position. Oh, let's look at an example of that. So let's go back into documents and touch bad, touch dad, and touch sad. Well, sad, no I. So we have all of these files and they all end in AD. So there's a few ways. If I wanted to see just those files, I could say, alright, show me everything that starts with something and ends in AD. Well, that gives me back bad, dad, and sad. Show me everything that has one character in front of AD. That gives me the same files. And let's say show me everything that starts with a B or a D followed by AD. Well, that just shows me bad and dad because S was not a valid character there for that position. Okay, so hopefully that illustrated that kind of well. Really what you use the most is probably this wildcard here. Sometimes you might use the question mark, and there's always use cases for when you might want to use the brackets. It's important to understand case sensitivity, especially coming from the Windows world where case does not matter that much. In the Linux world, everything's case sensitive. So these three file names that you see here, afile.txt, capital A file.txt, capital A, all uppercase file.txt, those are all three different files. So just to show you, if I touch a file and then touch a file and do an ls, those are two completely separate files, and they each get their own little file entry here. We talked about making directories, so we can do that with mkdir followed by the directory name. I do want to point out that with all of these commands, a lot of them were using these these relative paths, but we could use an absolute path if we wanted to. I could make dir home student documents2, and that'll be all fine. Let's get back there, ls, and we see there's now this documents2 directory. So there's lots of flags that you can use with makedir. In fact, I'd encourage you to look at the man page for it so that you can become familiar with some of them. One of them that we'll talk about is -p, and what it does is it creates directories along the way that don't already exist. For instance, if we look at documents2, I just created that, right? So there's nothing in there. But if I wanted to make a directory inside of documents2 called my stuff, and then a directory in there called, I don't know, CSCI 211, it says that there's no such file or directory. And what it's complaining about is that this directory doesn't exist, this documents2 / my stuff. And we know that because it's empty, right? So if we use the -p flag, -p, it's going to create all of what's known as parent directories. So the directory above it, it'll create this my stuff this time for us so that it can then create the CSCI 211 directory. Alright, so like most things in Linux, if you do not get any sort of output, it means that it completed successfully. And now I can go into documents2 and we can see my stuff, and I can change directory in there and see CSCI 211. We talked about deleting directories, so the rmdir is really only useful when a directory is empty. In any other case, we can just do rm-r or -R, either one, doesn't matter, and that will recursively delete the contents and the directory itself. As far as managing directories, there's a few things we're going to want to keep in mind. Obviously, we can use touch, and touch is going to update the timestamps only, so that's the same as with files. If we're going to copy a directory, we want to make sure we get its contents too. Okay, so coming back over here, do we still have anything in documents? Yes, we still have all of these files. So let's say I want to copy documents, and I want to copy that to documents 2. Well, copy really only works on, it's only going to copy over files here. So it sees this directory, but we didn't tell it to copy any of the files, so it's not going to worry about it, and it just omits it. So instead, what we want to do is, again, use this recursive flag, this -r, to tell it to go into documents and copy all of that stuff too. So when we do that, complete successfully with no error message, and we can change directory to documents 2, and we see that now there's a new directory in there called documents. And if I change directory to that one, it's all of those files that existed in our other documents directory up here. Okay, so just keep in mind, if you're going to copy a directory, make sure you use the -r flag. Move, we don't have to worry about doing any sort of recursive flags with move. So let's say I want to move documents and call it documents 3. Okay, if we do that, then documents doesn't exist anymore. Documents 3 does, and all of those files are still inside of documents 3. And then lastly, we can use symbolic links with directories, no problem. Alright, so that's it for this lecture. I hope you guys enjoy it and enjoy going through the exercises for it. If you run into any problems or questions, please let me know. If not, I'll talk to you guys in the next video. Thank you.